Okay, hello class. Math 250, section 4.1. Okay, so we are doing the chapter 4 right now. So in the chapter 4, so up chapter 3, we're doing the derivatives. And then we're going to do the anti-derivatives and the indefinite integration. So antiderivative means we need to go back to the before the derivative. Okay, so when you have the f of 3x squared, f of x equal to 3x squared, and then if you want to go back to the antiderivative, it's from actually here. So this is what they compare. Okay, so we are using the uppercase f of x as the antiderivative and then the f of x as a derivative. So we just see those, okay? So definition of the antiderivative is a function f is antiderivative of a function on the interval of I if the f prime of x equal to f of x. And then theorem for 4.1, representation of the antiderivatives. If the function is an antiderivative of the function on the interval I, then g is an antiderivative of function on the interval. If and only if g is the form of g of x is f of x plus c, or for all x in I where c is the constant. So notation of the antiderivative is the this is a different the antiderivative, right? So we have a dy dx equal to f of x, and then we put the dy equal to f of dx. So which are these two are exactly the equivalent differential form. So antiderivative of so if you integrate, so we use integration to the function, and then you go back to the antiderivative, okay? So the basic function is integral f prime of x dx is fx plus c. So yeah, that's what we're gonna use. Okay, so let's do the next page. So let's actually do the problem. So example 1, verify the statement by the showing that the derivative of the right side is equal to the integrand of the left side. So which means I wanna put it as this, say equal to that. So I want to say this is equal to the x to 4 plus 1 over x plus c. So verify statement showing that the derivative of the right side is equal to the integrand of the left hand side. So in order to check, actually we need to do the derivative of the right side. So if you do the d dx, x to 4 plus 1 over x plus c, which becomes d dx. I want to rewrite that, you know that it's going to be x to negative 1 plus c. And then it's going to be 4x cubed minus 1 times x to negative 2. C becomes a 0. And then we'll get as 4x cubed and minus 1 over x squared, that's exactly same as what we see. Which means we know how to go back to here. So these are the equivalent. Find the general solution of the differential equation and then check the result by the differentiation. So what we're going to do is I'm going to multiply dt both sides. I got dy equal to 3t squared dt. So in order to find the y, we put the integral and then 3t squared dt, and then the 3t cubed over 3 and plus c, which becomes 3 cancel, so you got t cubed plus c. And then if you do the derivative of t cubed plus c, you will get back to the 3t squared. Same thing here, so dy is 2x to the negative third power dt. So in order to get a y, which is the integral of the 2x negative third power dt, which is going to be 2. And then you put the, x with a negative 3 plus 1 over, well, I'm going to show it to you, negative 3 plus 1, and plus c, and then it becomes 2 to the x and negative 2 over negative 2 cancel. It becomes negative 1 over x squared plus c. Okay, yeah, so then we're going to learning the rules. So left side is a differentiation formula, and the right side is an integration formula. So if you integrate the constant, it becomes a 0. And if you have a kx, becomes a k. Kf of x is a kf prime of x. So we talk about differentiation. So now when you integrate that, integral 0 dx is c, integral k dx is kx plus c, k f of x dx is k equal to integral f of x dx. And then plus minus as an operation, you can separate these two. And then most important thing is this one. We use this a lot too, power rule. So yeah, same as here too, right? Okay, but different form. We go back to the original, okay? And then integral cosine x gonna be sine x plus c. Integral sine x dx is a negative cosine. Integral secant square x dx is a tangent x plus c, and integral secant x tangent x is a secant x plus c. Cosecant square x dx is a negative cotangent x plus c, and cotangent x is going to be negative cosecant x plus c. All right, so let's try do the problem step by step. All right, so I want you to complete the table following the rules we just learned. Okay, so when you have this, first of all, I want to rewrite the original problem. So this is a problem as x to the negative 2 power dx, right? And then we can use the power rule for the integrate. So integration is x to the, you're always actually adding the 1 to the power. Same as you put the denominator and then plus c. And then if you simplify the integrate, which becomes x to the negative 1 power over negative 1 plus c, which becomes negative 1 over x plus c. So that's it. And then for the second one, I'm going to rewrite it because there's no product rule for the integrations, okay? So I want you to multiply x to inside, get x cubed plus 3x dx, okay? And the integrate is going to be power rule, so x is going to be 3 plus 1 over 3 plus 1, and plus 3x 1 plus 1 plus 1 plus 1. So when you simplify, you get the x to 4 over 4, and then 3x squared over 2 plus c. For the third one, I want to square the 3x, which is going to be 1 over 9x squared dx. And then I want to pull out the 1/9. You don't need to keep that. And then as a 1 over x squared dx. And then easy to write the power rule. You might want to write the x to negative 2 dx. Now we can use the power rule, which is 1 over 9. Then the power rule has x to the negative 2 plus 1 over negative 2 plus 1 plus c. If you simplify, you get the 1 over 9 of x to the negative 1 plus c, which becomes 1 over 9 of negative 1 over x plus c, which becomes negative 1 over 9x plus c. Okay? All right, so find the indefinite integral and check the results by differentiation. Okay, so in order to do that, x plus c is x. Okay, so you got x squared over 2 plus 3x. And of course, plus c. There might be some constant. And number 2, same thing. The 3 plus 1 over 3 plus 1 plus 2x plus c. And then you got x to 4 over 4 plus 2x plus c. And then for the number 3, I might want to change the x to the 3 over 4 power and plus 1 dx. And then you can just use the x to the always adding 1 as a power. Same thing, you put it on the bottom here. And then plus x plus c. And then simplify. So it's going to be the 7/4. And this is going to be another 7/4 plus x plus c, which is if you multiply 4/7 on both sides, you get the 4/7 of x to the 7/4 plus x plus c. Okay, and then let me use another color because it's too crowded. Okay, so in order to do the number 4, easier way, there's no quotient rule either. So easier to do is this one. I want to actually change to the square root of x as x to the 1/2 power. And then you might want to do as the split it 1/2 plus x over x to the 1/2 plus 1 over x to the 1/2 dx. And then use a quotient rule, so which is you get the x to the 2 minus 1/2, which is a 3 over 2. X of 1 minus 1/2 is 1/2, and then 0 minus 1/2 is negative 1/2 of dx. Now you can use a power rule. Power rule. Dx here. So if you use a power rule, and then you'll get that as x to the 3 over 2 plus 1 over 3 over 2 plus 1. X has 1/2 plus 1 over 1/2 plus 1. And then x to the negative 1/2 plus 1 over negative 1/2 plus 1 and plus c. And then when you simplify, you get the 2/5 of x to the 5 over 2. And then you get the 2/3 of x to the 3 over 2. And then you get the 2x to the 1/2. And then plus c. All right? I just skip the 1 steps, okay? So hopefully you're fine. All right, let's go to the next page. So we will continue to do that. So it's a little bit different, so I want to show it to you too. So you know to do this. Okay, so first of all, this one I don't think I want to use a power rule, but you can use a substitution, but that will be the later step. Okay, so I want to square the 2t squared minus 1. So if you square it, you get the 4t4 minus 4t squared plus 1 dt. And then just using the power rule from here. So 4t4 plus 1 over 4 plus 1. Subtract 4t 2 plus 1 over 2 plus 1 plus t plus c. And then when you simplify, you got 4t to the 5th over 5 minus 4t cubed over 3 plus t plus c. That's all. And then for the 6th, so sine x becomes a negative cosine, so negative 2 cosine x. And then cosine x becomes a positive sine x. So that's it, and plus c. That's pretty easy, right? And then the cosecant cotangent, which is 1 becomes a t minus cosecant cotangent becomes plus cosecant t, and then plus c. For the theta square, which becomes theta 2 plus 1 over 2 plus 1. And then the integral secant squared theta becomes a tangent theta. Then you got theta cubed over 3 plus tangent theta plus c. For the 5, solve the differential equations. Okay, so we're going to find the what? It's going to be a f of x, okay? So in order to find that, so what I do is, in order to find the f of x, I need to do integrate f prime of x dx. Well, f prime of x is 4x dx. And then I get 4x squared over 2 plus c, which equal to 2x squared plus c. But f of 0 equal to 6. So if I so this is so now your f of x is 2x squared plus c. Now f of 0, which is I can use a 0 as x, which is same as a 6, which is a c. So c is a 6. So f of x becomes 2x squared plus 6. Same thing. I'm looking for the f of x in here. So not f of x. Sorry, should be h of x, right? So in here, I'm looking for the h of t. So which means in order to the h of t must be integral h prime of t dt. And then h prime of t is 8t cubed plus 5 dt. And then it becomes 8t to the 4 over 4 plus 5t plus c, which is simplified as 2t fourth plus 5t plus c. So I got 2t fourth plus 5t plus c. And then h is 1 right now, so plug it in 1. And the h of 1 is negative 4, so 2 plus 5 plus c. And then negative 4 equal to 7 plus c, subtract 7 both sides, negative 11. So h of t becomes 2t to the 4 power plus 5t and minus 11. All right, so that's all. All right, next page. Now we have a double prime, second derivative. So in order to find the, when you have a second derivative, we can find the f prime of x. So f prime is the same as integral f double prime of x dx. So f double prime is 2 dx, which is 2x plus c. So now we have f prime of x is 2x plus c. Now I want to looking for this times the 2c here, because there's f prime, there's a f. So I want to say c1 for the f prime of x. So plug it in 2 in the f prime. I got 2 times 2 equal plus c1. And the f prime of 2 is a 5 plus 4c1. And then c1 equal to 1. So I got f prime of x as 2x plus 1. Now, in order to find the f of x, I need to put it into the integral f prime of x dx. And then f prime of x is a 2x plus 1 dx, which is 2x squared over 2 plus x plus c2. And then that's f of x. And then simplify, you get the x squared plus x plus c2. But f of 2 is a 10. So 2 squared plus 2 plus c2, which is a 10, which is 4 plus 2 plus c2. So c2 is a 6. Oh, it's a 4. Now f of x is x squared plus x plus 4. Okay, same way here. So in order to find the f prime of x, I need to use the integral f double prime of x. Becomes negative x plus c, which is f prime of x, f prime of 0, negative cosine 0 plus c1 is going to be 1 minus 1 plus c1. So c1 is a 2. So f prime of x, now it is negative cosine x plus 2. Now, in order to find the f of x, now we put the integral f prime of x dx. Now we have f prime negative cosine x plus 2 dx. And the integration is cosine is a sine x, negative sine x, and then plus 2x plus c2, which is f of x. F of 0, which is negative sine 0, plus 2 times 0 plus c2 is a 6, which is sine 0 is a 0, 2 times a 0, so c2 is a 6. So in order to get f of x, you got negative sine x plus 2x and plus 6. And that's what you're looking for. All right, thank you for listening.